of math. Every time we divide, we already know the path. Then we multiply, all we gotta do is roll the die.
Okay, let's move on to the next page. Remember, we're in Module 8. This is Lesson 2, and this is Example 1 now, finding the probabilities. A student tossed a fair-sided die 200 times and recorded the results. Find the theoretical, theoretical probability of rolling an 8. Write your answer as a percentage rounded to the nearest tenth if necessary. Okay, in this example, you have an 8-sided die. And each of these, I don't know how to draw that, but it's equally likely to get a number. So, remember we have the all, and then what we want are selected. So our total is 8. There's 8 sides to the die, and we're trying to just roll one specific number. Let's try that again. The 8-sided die is from up here, and then this kind of confusing. This is the specific number we want. To roll an 8 is just, write it out. Super helpful. This is the 8-sided die, and how many of those numbers are 8 is just 1. So our theoretical probability here is 1/8. Now it tells us to write it as a percentage. So this is a fraction. You can put this into your calculator. I like this calculator called Graphing Calc 83. It's free. And it looks like a graphing calculator, 1 divided by 8. Okay, so there I have a decimal, 0.125. And to go to a percent is you just multiply the number by 100. So 0.125 times 100 gives me 12.5%. So this is 0.125 as a fraction. That's not a fraction. Blah. Good thing there's a right. That is a decimal. And to go from a decimal to a percent, you're going to multiply that number by 100, and we get 12.5% is our theoretical. Okay? All right, find the experimental probability of rolling an 8. Okay, now this is the actual, so let me just, this here is based off of these numbers. Okay, and do that to the nearest tenth. Okay, so we have to add all of those numbers up. So let me add up all of those numbers. 28 plus 19 plus 24 plus 22 plus 21 plus 18 plus 26 plus 42 gives me 200. Okay, so I'm just dropping my pen and throwing stuff around here. Frequency means count. So basically, the computer in the simulation, or the student tossed it and got the number 1 on their die 28 times. Does that make sense? So it's a count. So we got, our total here is, just double checking that it added up there to 200, and this is what we want. We wanted, how many times did they get an 8? Well, if you look over here, they got that 42 times. And so let's convert that to a fraction and decimal. This one's kind of nice because if you just divide it by 2, you'll get 21 over 100. And that's what percent means, out of 100, so this would be 21% is your answer. So the experimental does not match the theoretical. But if you did this a bunch more times, guess what would happen? We would go closer to 12.5%. All right, so I got 3 examples below. It says directions. In questions 1 to 3, skip one of these. When you skip one of those, go ahead and put an X through the number. That way you can have more space to work on, or it's not meant for you to do everything. But the goal is, if you need more practice, then you could do all of them. Okay, so I'm going to go over those with you. So go ahead and press pause, do the 2 questions that you want to do, and then press play when you need some hints, or if you want to do that with me step by step. All right, number 1, a student spun a spinner with 4 equal sections. So let's just draw it, super helpful. 100 times and recorded the result. So you have red, blue, green, and yellow. Find the theoretical probability of spinning a blue. So probability, this would be better, probability of blue is equal to the total versus the select, what we want. So total is how many colors? There are 4 colors, and select is blue. And okay, pay attention here. Blue is not the frequency here. Okay, remember this. This here is matching the experimental, so don't do that. In this case, you're just looking at the spinner over here on this circle here. So 1/4. Remember, you don't need to calculate. You can just type in your calculator. Remember, if I just get this to out of 100, there's my fraction, and 4 parts out of 100%, right? Like 4 pennies out of 100 is 4 cents. 4% is your answer, is the theoretical. All right, let's find the experimental now. Same thing, we want blue. And in this case, the experimental is we had 100 times. And blue came up 38 times. So that would give us a decimal, and then you multiply by 100, and you would get 38% is your answer. Okay, so through a fraction is easier, and it says rounding to the nearest tenth. Let's do a quick fraction lesson. That would be, the tenths would be this spot right here. This spot is the hundredths, and so that helps you round up or round down to get to the tenths. Okay? All right, let's try question number 2 here. A student flipped a coin 125 times and recorded the results. Find the theoretical probability. So let's go and do the theoretical probability. Again, this is the total, or another way of saying is all versus what you want, the select. Well, if there's only 2 choices, it's either going to be heads or tails, so it's only 2 of them. But we're trying to get heads, and so like you can just write this out, right? You did the coins before. There's 2 coins, so that's the total, and you're trying to select a head, so that would be 1/2. And again, you can just put that into a decimal in your calculator. That would give you 0.5, and then if you multiply that number by 100, this gives you a percent. So 50% is my answer. Okay, so review. 1/2 is my fraction. 0.5 is my decimal, and then 50% is my percent. Okay, so remember, the chart here refers to the experimental probability. So now we need to find what happens actually in our experiment. So the total, how many times did I flip this coin? 125 times. And what did we want, or what did we select? We selected heads, which is here, 73. I'm just going to change that into a, let's show you the calculator one more time. 73 divided by 125, enter. You get 0.584, and if you multiply with that number times 100, you get 58.4. So 0.584, and then we multiply this by 100, then you will get 58.4%. So in theory, we should get only 50% heads, but ours was 58, so ours was a little bit higher. All right, let's go ahead and try question number 3. All right, let's go over question number 3. A fair 6-sided die is rolled 150 times. Find the theoretical probability of rolling a 3. So the theoretical probability is all of your probabilities over some of them. That's another way of saying it. So we have 6 die, and there's just one number. Again, list out all the numbers, that might help you. 1, 2, 3, 4, 5, 6. And we're trying to roll a 3, so that's only one number, so 1 out of 6. If we put that into your calculators, you'll get a repeating decimal, 1.6666, right? And so how do you round to the nearest? Well, first of all, we're going to multiply by 100. Now that would give me 16 point. And so my decimal would now be here. This is the tenths. And so I'm going to actually look at the hundredths. And this number is 5, 6, 7, 8, or 9. You're going to round this number up. So that would be a 7. 16.7% is our theoretical probability. The experimental probability, we're going to look at this chart here. So we have the all. In this case, that would be the 150. Rolling a 3 is, this came up 27 times. And so if I put that into my calculator, let's do that. 27 divided by 150 gives me 0.18 is my decimal. Okay, common mistake, 0.18 is not a percent. If you did put the symbol percent, that would be less than 1%. So multiply that by 100 to get your percent. Our percent is experimental. That was pretty close, right? 18% matched close to the 16.7%.
Just spray the liquid formula onto the mess, then wipe it clear, and enjoy the result. Mr. Math. Stay clean and calculated. Order now at www.gpproductions.com and get an additional